So I go off down to Varian over in the Bay Area in California, who makes the machine, the Varian Corporation. I said, look at this data here. It makes no sense at all. What's going on here with this machine? It's got to be something you can explain, right? And they looked at it and they said, Dave, you're cooling the sample. We say it's superconducting. But in as much as you're heating the sample, we have no idea whatsoever what's going on. And I said, what do you mean by superconductivity? I mean, I don't know what superconductivity is. And they said, well, it's literally a material that is so sensitive to magnetic fields. And I said, well, how sensitive? They said, well, a superconductor will respond to a magnetic field of 2 times 10 to the minus 15th ergs. I said, that's great. What's an erg? They said there's 10 to the 18th power ergs in a Gauss. I said, what's a Gauss? And they said, well, the Earth's magnetic field that a compass aligns with is about 0.56 Gauss. So if a Gauss is just a little bit more than the Earth's magnetic field, then an erg is 10 times 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 10, 18 times. There's that many ergs in a Gauss. So an erg is a little bitty amount of magnetic field. In other words, they talk about the charge around an electron. They talk about that in ergs. 1 electron. So that's a little bitty tiny measure of magnetic field. Okay? A superconductor responds to 2 times 10 to the minus 15th ergs. Or 0.000000000000000000015 times in a 2 of one of those. Now that isn't just little bitty. That's nothing. That's nothing. In other words, if a star twinkles in the heavens, it affects the superconductor. And this is really sensitive stuff. In fact, come to find out that the way they see your thoughts in your brain is with a superconducting quantum interference device called a squid, a superconducting ring that they put around your head, and they give you something sweet, and when you taste it, this part of your brain lights up. And they see it with a squid. Or they give you something sour, and this part of your brain lights up. Or you get mad at your wife, and the whole thing goes crazy. They actually see your thoughts with a superconductor. I said, boy, this is sensitive, isn't it? And they said, so, when you understand that the heating element on the furnace, it's bifilar wound, so the coils go up like this, they get the top, and they come back down, and they actually cross each other so that they cancel each other's field. So electricity's going this way, and then it comes back the other way, but it's crossing, so the wires go like this, on top of each other. And that's called bifilar winding. They use it in electronics. And that's so the fields cancel each other and there's no field. But in fact, it is impossible for the wire to really be exactly in the same place. They have to be right beside each other. And when they do that, there is that tiny residuum in the field, this little bit of imbalance that isn't exactly the same. And that's enough field to affect a superconductor. And I said, well then, you think this stuff could be a superconductor? And they says, well, if you're cooling it, we'd say it was. So I actually got a bunch of books over in England, and I started to read about superconductivity. And this is really important, people, to understand, because this is the basis of everything. I think it was what Ramtha says, you call this superconductivity. Okay. All right, I actually took this white powder, and I put it on the table, and I get a voltmeter. Now, a voltmeter has 2 electrodes, and you hook it up on a piece of wire, and you turn on the battery pack. It's actually a battery-powered machine, and it measures the conductivity on the wire between these 2 electrodes. So I take this little instrument, and I set it on my powder, and I put it at both ends of the powder, and I turn this battery pack on, and I figured, this is just going to be like touching these electrodes together. It's only dead short, right? It's a superconductor, right? So I put it on, turn it on, nothing happens. I thought, well, this isn't a perfect conductor. This is a perfect insulator. Nothing flows at all. And then I get to the second chapter in the book. find out that a superconductor, by definition, is not a perfect conductor. A superconductor is a material that does not allow any external magnetic field to exist in the sample. Okay? No external magnetic field can exist in a superconductor when it's superconducting. So my battery pack actually has electricity in it, and it requires a voltage potential to get the electron off the wire and into the sample. And it takes the voltage potential to get the electricity out of the sample and in the wire. But by definition, the sample, if it's a superconductor, doesn't allow any voltage potential to exist in it. So there's no way to get the electricity off this wire and in the sample. So that means it's absolutely worthless. Well, then I got to chapter 3. And then it says that everywhere in the superconductor, it's like a laser. There's a single frequency light in the superconductor. So everywhere in the superconductor, it is single frequency of light, all one frequency. And what it said is you have to resonance frequency tune the vibrating electron on the metal to agree with the frequency of the superconductor. And when you have it tuned to its exact correct match with the superconductor, then the electrons will pair up and go on as electron pairs in the superconductor with no push at all. Because they're always moving on the wire continually anyway, not really going anyplace. But when you give them a superconductor and resonance frequency tune them, they literally go on to the superconductor because they're seeking the path of least resistance. And that's in the superconductor. So all these electrons, the spin 1/2 electron and the spin 1/2 time reversed electron, now become spin 1 boson and go on as light. That's real important to understand. The spin 1/2 electron and the time reverse spin 1/2 electron pair together and form a spin 1 boson, and they lose all particle aspects. So this particle plus this particle is no particle. It's physics, don't ask me, it's just physics. So 1/2 plus 1/2 is 1, and that has no halves. Anyway, it's just light. Now the really strange thing here is an electron exists in space-time, and another electron exists in space-time. And these two electrons can't cohabitate, they won't get together. They exist in space-time, they won't occupy the same space-time. But when they pair up, then they lose all particle aspect, and millions of phonons can exist in the same space-time. Isn't that weird? I mean, gosh, what's going on here? So what happens, as long as you have the wire resonance frequency tuned to the vibrational frequency of the superconductor, and you have it attached to a source of electrons like the Earth, drive a stop on the ground, hook the wire up to it, they literally go on forever. And ever, just keep going on, and they don't have to come off. They just go on, keep going in there, just keep going. And now you say, okay, how do I know they're in there? There's no way to measure them when they're in there. All your instruments are based on deflection or differential, but there's no way you can measure differential because there is no differential. There's no voltage. A perfect superconductor can flow up to 200,000 amps with no potential. 200,000 amps per square foot with no potential. So you can actually put this superconductor up, flowing 200,000 amps per square foot, and hold it against your cheek, and there's no tingle, there's no tickle, there's no sparks, nothing, because there's no volt. Okay, it's just light. Like liquid light flowing. Now the other thing you need to understand is the light does not flow at the speed of light. The light actually flows at the speed of sound. Which is very important. It flows within the superconductor at the speed of sound. So actually you can kind of see it move. You know, it's kind of like liquid light flowing in there. So how do you know what's in there? Well, what you do is you read the amount of magnetic field that's being produced around the sample. So now we're at another thing we got to learn. A superconductor, when it is flowing current inside the superconductor, forms around a magnetic field, just like a wire when it's flowing current forms around a magnetic field.